All right, what's up, everybody? Moving on to lesson 3.4. Last lesson, we worked on algebra proofs. Today, we're going to start our first lesson on geometry proofs or geometric proofs. We're going to do 2 lessons of these. This first lesson is going to be on segments. Our next lesson, 3.5, is going to be on angles. Okay, so we're going to get going into geometric proofs. Okay, our objective is to solve problems using segment and, I forgot to change this. It's just segment addition. Okay, Joe. So first, to review, let's go through. Given all of the right, these are all of the correct answers. All you need to do is be able to put them into the correct place to solve this proof chart. Right, this is an algebra proof chart. So go ahead and let's start filling these in. Okay, so remember, always start with getting that easy money, right? Always give the 3 for sure given answers, right? We always take what is given to us and we write that as the first statement. So for parentheses x plus y, close the parentheses, equals 48, right? Our first reason will always be given. Okay, and always rewrite what you're trying to prove as your last statement, x equals 6. And since we are given a word bank this time, right, it'd be super helpful to actually cross these out as we go, right? So we've used given, we've used x equals 6, and we've used 4 parentheses, x plus y equals 48. However, notice in this example, they actually gave 2 pieces of information to us. Wow, that's so nice of that problem to give us 2 pieces of given information rather than just 1. Also, you can see that you have a second given here, right? So let's include that second piece of given information. Y is equal to 6, and we know that that is given. Okay, and again, being smart students, we always cross out what we've already used, so that way we know not to use it again. Okay, next, now that we have 2 variables, we have an x and a y, but they told us that y is equal to 6, we can simply just plug that in there. That's super easy. So then we see our option here, right? 4 parentheses x plus 6 equals 48. Right, so we have used this one, but now what is our reason? How did we do that? What allows us to take 6 and plug it in for y, right? Our correct answer here is substitution. Substitution. If something is equal to another, you can replace it or substitute it. Okay, I'm going to abbreviate for substitution. We didn't use substitution too much in the last lesson, but it will come up a lot more in this lesson. Okay, so now if we have parentheses, right, we need to then take this 4 and multiply it across, and we end up with 4x plus 24 equals 48. We see that that is one of our options. 4x plus 24 equals 28. 48. And then if we multiplied across these parentheses, we then used the distributive property. Distributive, and I'm going to shorten that as well to just DISTR. That's the distributive property. Okay, if you need to write it off to the side to solve, 4x plus 24 equals 48. We need to get rid of 24. We subtract 24 from both sides, which would cancel out, and we would end up with 4x equals 48 minus 24 is 24, which is this right here. 4x equals 24. What did we do? We subtracted 24 from both sides. So that means we used the subtraction property of equality, or the SPOE. And lastly, 4x equals 24. How can we get rid of 4? We divide by 4. 24 divided by 4 gives us 6. That is our last answer there. We used that answer, and now we end up with x equals 6. We've already used that, and we divided, so we used the DPOE. Okay, good. That was just some quick review from what we learned last lesson. Okay, these are all of your properties of congruence and properties of segment additions. Okay, these are included in your notes, which I realize I have not talked about, but just like always, if you go into Canvas here on your homepage, I've included the notes 3.4. Okay, those are there on your notes. Okay, we're actually going to spend some time talking about these. Okay, reflexive property. If all this says is that one thing is congruent to itself. Okay, think about reflexive means that you're looking at yourself in a mirror, right? Your picture in the mirror versus your actual body, they are the same thing. They are congruent. Symmetric means that you can have the same thing on either side. It doesn't matter which side it is on. So if A is congruent to B, all the symmetric property says is that you can switch it around and say that B is equal to A or congruent to A. Okay, the transitive property of congruence. Okay, this is not just the property of congruence. This is just a general math property. If A is congruent to B and B is congruent to C, then A is also congruent to C. Sometimes a transitive property can also be explained as the substitution property, because technically, right, if you look, right, if we take our original sentences, A is congruent to B and B is congruent to C, since B is both congruent to A and B, technically you are then substituting in C where B used to be. All right, so sometimes transitive and substitution get used as the same, okay? And then your definitions and postulates about segments. The segment addition postulate. If point C is between A and B, then AC plus CB is going to equal AB. And if you wanted to draw an example of that, right, if you had 3 points, and this was point C is between A and B, right, that means that AC plus CB is equal to the entire length CB. Okay, that's like saying if you have 2 and you have 2 and you add them together, that makes 4. Okay, you're taking 2 smaller segments, adding them together to say that it equals the larger segment. Okay, also, a lot of times you will see when we're doing these proof problems that the answer is going to be in the definition itself. It's segment addition. We are adding segments together. Okay, so and then next one, definition of segment congruence. Okay, if segment AB is congruent to segment CD, then that means AB is equal to CD. And you might be thinking, well, like, well, what's the difference? Okay, technically, when we have a congruent sign, right? We've said this before. Technically, congruence means same size and same shape. Okay, whereas when we just have an equal sign, that's literally just talking about the number or the length, okay, not necessarily talking about the shape, okay, more just only talking about the size, okay. But again, same thing, right? Definition of segment congruence, you can see that we are talking about congruency, so that's how you will know when we are doing these problems that you're going to use the definition of segment congruence. Okay, the next one, definition of segment bisector. Bisect means to cut into half. Think of it literally means cut into half, right? Bi means two pieces. Sect means to cut, right? A geometric figure that divides a segment into 2 congruent halves. And definition of a midpoint, a point that then bisects a segment, right? So bisect and midpoint also kind of go hand in hand. These are the reasons and definitions that you're going to be using for your proof charts today. All right, so here's an example of a proof chart. You don't have to write anything down. This example is not in your notes. Okay, this is one that is already done for you. Remember, if we were to have a table, this would be your statements, and these would be your reasons, right? All right, so let's just go through this. Let's take a look. Find the value of A and xy if y is between x and z. Right? If xy is equal to 3a, so we see that that's right here. Xy is equal to 3a. Xz is equal to 5a minus 4. So it means the entire thing, right, is 5a minus 4. And then yz is 14. All right, so this problem incorporates both geometry and algebra. So there's a little bit of both. You will see the properties that we used last lesson in algebra along with the properties that we will use here, okay? So xz equals xy plus yz. So I actually hate that what they said right here, okay? This here, ladies and gentlemen, would be an example of, I'm going to write off to the side because I'm really bad at writing, right? But that would be segment addition, right? Segment addition. We see that we are taking xy, which is a small segment, plus yz is a small segment, and it is equal to xz, which is the large segment, okay? Large segment. Next, okay, so xz is the whole one. They have now changed xz to 5a minus 4. They've changed xy to 3a, and they've changed yz to 14. Notice they used different colors, so that way you know that they're matching up. That is the substitution property. If they tell us that xz is equal to 5a minus 4, then we can substitute that in, okay? And so now we are solving for a, right? We have an equation. Okay, we need to combine like terms. We need to get the a's all together, right? So they have subtracted 3a from both sides. Remember, if we're using the same properties of what we talked about last class, then we actually would call this SPOE because we are subtracting the same thing on both sides. And also, since we are combining like terms, we would also say that this is simplify. Simplify. Okay, now the textbook sometimes, in my opinion, puts in extra unneeded steps, right? If we subtract 3a, I wouldn't have written this as a step. I would just do it and then rewrite this as our answer. But 5 minus 3a gives you 2a. 3a minus 3a, those cancel out. And they just said that they're simplifying. Personally, I think that's unnecessary, but that's okay. We keep going. All right, same thing here. Again, that's why I always like to write my work off to the side, so that way I don't make my chart have unnecessary steps. But here we have 2a minus 4. To get rid of minus 4, they are adding 4. They are adding 4 to both sides. And again, I would change this to APOE because we are adding equally to both sides. Negative 4 plus 4 cancels out. 14 plus 4 gives us 18. We have 2a minus 18. Again, they write simplify. I don't like that personally, but it's the textbook. Okay, our next one is that we divide by 2 to get rid of here. Those cancel out. 18 divided by 2 gives us 9. Again, instead of saying divided by 2 each side, we would say that this is using the DPOE, the division property of equality, and we get our answer of a equals 9. Okay, now it also says we found a, we did that, find the value of a, but now it also says that we have to find xy. So if we're looking for xy right here, we just, now that we know a, we plug in 9 in for a, and we find that the length of xy is going to be 27. Okay. All right, so if we think about segment addition, these are not necessarily proof problems, but we can still use that same critical thinking and problem-solving skills to actually find out these answers. Find the length of the given segments. Well, let's take a look. If the whole segment is 5.8 and part of the segment is 3.7, use your segment addition. We know that PR plus RS is going to equal the entire length of PS. And even though we're not creating a proof chart, we know that this is segment addition right here because we are adding two small segments to equal a large segment. Now we can substitute. We're looking for PR, so we don't know what it is. We can just leave it as a variable such as X, right? RS, we actually know the answer to, 3.7. And we know that PS, the entire length, is 5.8. All right, now if we're solving for x, all we need to do is subtract 3.7 from both sides, subtract 3.7 from both sides. Those cancel out, and we end up with x is equal to 5.8 minus 3.7. 8 minus 7 is 1. 5 minus 3 is 2. Okay, and again, even though we're not creating a proof chart, since we subtracted from both sides, we just used SPOE to get our answer that PR is 2.1, right? So this is PR. Okay, next, find the length of JL. JL is the entire thing. So again, segment addition, we know that JK plus KL has to equal JL, right? That's segment addition. You're taking your two small segments, adding them together to equal the entire large segment. Now you can substitute and plug them in. JK is 0.75 plus KL we see is 0.35 is equal to JL, and that's what we don't know. You can put in an X there. All right, 0.75 plus 0.35 ends up giving you 1. Well, let's see here. That's 10. That's 10. So 1.10, okay, is JL. Okay, next, find the length of WY. That's what we're looking for. Notice they don't give us anything except for the entire length. Well, let's do the same thing. We know that WY plus YX has to equal WY, right? Now, this one we only can plug in and we can only substitute 8.8. right? So that's not really necessarily going to help us. We can't have two variables there. But what do we see? What do we notice, right? These here, ladies and gentlemen, remember, these are the congruency marks, okay? These are congruency marks. So if you see that they are congruent, that means you know that they are the same thing, okay? So you can say that WY and YX, WY is congruent to YX, right? Because that, and again, we're not making proof charts, but this is by definition of congruence because they show us that those two lines are congruent. And if those are equal to, or if they're congruent to each other, that means we can say that WY is equal to YX. When those have to combine together, WY plus YX equals W. Oh, I'm so sorry. This here, ladies and gentlemen, should be WX, the entire thing. WX is the entire thing, right? And we know that if we combine those together to equal the whole thing, and we know that they are now the same thing, now if we replace them with an X, they are both X. So you could say that 2X has to equal 8.8, right? Because they are the same. They have to be the same thing. So 2, then we divide by 2, we would find that X is equal to 4.4. So both of these, since they are congruent, have to be 4.4. Okay, use your definitions and reasons of why you can why you can prove that these things are true. Okay, given that segment AM is congruent to segment WU, we know that AM is equal to WU. So your key, right? Whenever you change from a congruent sign to an equal sign, or the opposite, whenever you change from the equal sign to the congruent sign, you are going to say that this is proven due to the definition of congruence. Proven by the definition of congruence. Whenever you change from a congruent sign to an equal sign, all that is saying that is if our two things are congruent, that also means that they are equal to each other. Okay, if given that E is the midpoint of BD, again, draw a picture if you need to. E is the midpoint of BD, so we know that this is segment BD, and it says that E is the midpoint. Now they're saying that we can prove that BE here is congruent to ED. How? Well, again, keywords. We know that this is true because that is literally the definition of a midpoint. Okay, given A bisects segment CT. So again, if we have segment CT, it is super helpful to draw a picture so you can visualize it. If A bisects it, remember we said bisects means to cut in half. Now, if this is point A, notice these are very similar, midpoint and bisects. Okay, CA is congruent to AT, right? This is definition of a bisector. Look at me writing in cursive and stuff. Okay, so here is now an example of a proof chart. Okay, a lot of times you will be given pictures. Not always will you be given pictures, but I'm going to try to make sure that you get pictures as much as possible. Okay, so things that always draw on your pictures to help make sense of what's going on. So prove that CE is congruent to FE, right? CE and FE. You have to prove that. And ED is congruent to EG, then prove that CD is congruent to FG, right? So notice that this was given as like a 3-part question. We're only going to focus here, right? This is our proof. Okay, and we are given that CE is congruent to FE, so we can put congruency marks there, right? Those two lines are congruent. And we are also given that ED, where is ED? ED, I'll use a different color here. ED is congruent to EG over here, okay? So we know that the blue lines are congruent to each other. We know that the orange lines are congruent to each other, okay? Obviously this one's already done for you, but you can see that the easy money questions are still there. Rewrite your given statement. Always use given as your first reason. Whatever you are trying to prove is always going to be your last statement, okay? So think, How can we go from here to here? That is what you need to do when you're filling in proof charts. What reason can we use that proves how we go from one step to the other? Okay, so how do we change from CE is congruent to FE, changing to CE is now equal to FE? Remember, anytime you see a congruent sign changing to an equal sign, you're going to use the definition of congruence. Okay, now we're saying CE, which is there, plus ED, which is there, is equal to CD, right? So you're saying that one small segment plus another small segment is equal to the entire large segment. Remember, you're adding segments, so that therefore you know that this is true due to the segment addition postulate. Okay, next, FE is congruent to EG, or sorry, FE plus EG is equal to CD. Well, now we started with CE and we replaced it with FE. Notice, we said that these were equal, so now they have just changed. Okay, and now you used to have ED, but that's equal to EG. We replace it. When we replace things, that is the substitution, right? Substitution, whenever you just swap them out for things that are equal to each other. Okay, and now FE plus EG is equal to FG, right? FE is this blue one plus EG is the green one. Sorry, green. Wow. Orange one is equal to the entire FG. And once again, ladies and gentlemen, we are adding two segments together, so we know that that's a segment addition postulate. Okay, and last one, since we said that these two, FE and EG equal CD, and here we also said that FE and EG are also equal to FG, that means we can replace them again, right? If we said it's equal to CD and we wrote them again, that means we can replace these two with CD, which is substitution again. All right, and now we go from an equal sign to a congruent sign. If CD, the entire length here, if CD is now equal to FG, then that means they can also be congruent. And again, we're changing from equal sign to congruent sign. You're always going to use the definition of congruence. Okay, let's do another one where we are actually going to fill in the blanks. Okay, always start out getting the easy money. Okay, here I am not going to rewrite it because they gave us three things, right? If we were actually filling these in, we would write all of these right here for A because it is given. Excuse me. Okay. Next, AC equals CE and BC equals CD. Well, how do we know that? Let's look at what they actually told us. C is the midpoint of AE. C is the midpoint of AE, right? And we remember the definition of midpoints means that it cuts it perfectly into two congruent halves. So that means AC is congruent to CE. Okay, notice that's what it says here. Then what else does it say is given to us? C is also the midpoint of BD, right? So C is the midpoint of this line, which means that these are also congruent to each other, right? So since the information given to us was that C is the midpoint, right? We know that this reason that these are equal to each other is by the definition of the midpoint. And again, I'm not going to write the whole thing. All right, definition of midpoint. Okay, next. Now we're saying that AE is congruent to BD. Notice that was what we should have had here in our given statement was AE is congruent to BD. Now it's just changing from a congruent sign to an equal sign. We know that whenever we change from an equal sign to a congruent sign, we're just going to say that this is true because of the definition of congruence. Okay, and now if it's saying that our reason, now it's the opposite. They give you the reason, we have to know what to put as our statement. If we are given the segment addition postulate, that means that we have to add together two small segments to equal one large segment. Okay, this one we're actually going to fill in 2, right? So if we fill in 2, I have this written down here, right? We are going to do, let's use the same color. If we're talking about AC and CE, we will say that AC plus CE is equal to AE. And then if we use the other color that we have, talking about the other line, we know that D, or here, let's use the same letters that they use, BC plus CD is going to be equal to BD, right? We're saying that two small segments add together to give the whole segment. Okay, so now AC plus CE is equal to BC plus CD. Okay, this here, ladies and gentlemen, is due to the substitution property, but is also similar to the transitive property. Okay, and how? Why? Why can we say that? How is that allowed? And the reason why we can say that, because up here we said that AE is equal to BD. Well, here we said that AE is equal to AC plus CE. So here, AE is just being replaced with AC plus CE. BD is being replaced with BC plus CD, right? So we are substituting. We're just replacing them. Okay, now here in F, AC plus AC. Notice here, again, we are changing CE to AC because we said that here up in statement B, AC is equal to CE. So if CE is equal to AC, we can just replace it with another AC. And same thing up here. We said that BC is equal to CD. And since we use BC, that means we can also replace it with CD again. So we have substitution property there. Okay, now we have an algebra problem. Okay? It may not look like an algebra problem because we have weird variables, but AC plus AC, technically those are like terms. You can have 2AC is equal to CD plus CD 2 times CD, because if you're adding two of the same thing, you just you can multiply by 2. Okay, next, division property. We know that we have to divide. Well, we're going to divide by 2 on both sides. If we divide by 2 here, we divide by 2 here, the 2's will cancel out, and we just end up with AC is equal to CD. And if we switch from AC is equal to CD to segment AC is congruent to segment CD, all we have done is change from an equal to a congruent sign. So that there, ladies and gentlemen, is the definition of congruence. All right, so there's our example there. And we got one more example. Okay, fill in the blanks, complete the proof chart. Okay, given JL is congruent to KM. Again, mark up your picture. JL, where's JL? JL is here, and that is congruent to KM, which we see is here. I'm going to write a little bit below it, so that way, since I'm using the same color, I want to use the same color to show you that they are the same length, but I don't want to draw over the top of them because then you won't see what it is actually showing. Okay, so that is always given. Notice, what is our reason here? We have changed from congruent to equal sign, right? So that means that there is the definition of congruence. Now we have segment addition postulate. We're going to add together segments, right? You add two smalls to equal the big. Okay, but notice we have to fill in what our big segment is. JK, if I use a different color, JK is here, right? And then if I use yet another color, plus KL is there, right? Green plus yellow, JK plus KL is going to give us JL. So that is JL. And then KL plus LM, again, trying to mix up my colors. KL, that's already in yellow, plus LM is in orange. KL plus LM is going to equal KM. KM. Okay. And now here in step D, we have now changed to JK plus KL is equal to KL plus LM. Okay, so notice, look at what I've written here in my terrible handwriting, JL and KM. Well, we just said that those are equal to each other up there. And if JL is equal to JK plus KL, I can then replace that with there, and then I can replace KM with KL plus LM. That is being replaced there. And if I'm replacing them, we know that I'm using the substitution property. Okay, now JK plus KL equals KL plus LM. All right? And again, even though it's an abnormal algebra problem, right, it is still technically, in a way, an algebra problem. If we have KL on both sides, we can subtract KL from both sides, and then those would be eliminated, right? So that is why we're using SPOE, because we are subtracting KL from both sides. Okay, and if we subtract, that means that they actually end up canceling out. Okay, and again, is where the textbook uses that unnecessary step. Okay, but since those cancel out, we are now just left with JK is equal to KL. Sorry. We subtracted KL, so that KL would have been canceled out, and we are left with LM. JK is equal to LM, and now whenever we switch from an equal sign to a congruent sign, we know that that is going to be the definition of congruence. I know that this is a little bit confusing and a little challenging. I promise you we'll talk more about it in class. I believe that's all I have. Please come to class with lots of questions. We'll work through this together. I believe in us. Go team, go Mustang.